So today we're going to be talking about Lewis structures. And so yesterday we introduced that by you building them without knowing how to build them. So you did puzzle pieces and then you learned how things bond. So for example, if you recall yesterday's activity, if you had carbon always made 4 bonds because it has 4 valence electrons and it will need 4 more. So each bond basically is an additional valence electron that it will get as it shares. Have I told you anything you didn't already know? So your Lewis structure, this is a Lewis structure. So I'm going to tell you how to do this. So there are 7 steps that, if you Google the 7 steps to do Lewis structures, like you won't find it. It's kind of like Miss Freeman's 7 steps. But if you do what I'm telling you in the order that I tell you, it will work every time and you will be super successful. But if you just start drawing lines, it's not going to work out. So anyway, we're going to do this one as an example, and then I'll do a harder one and then a harder one, and then tell you some fancy words, and then you'll be fine. So how did I do that? So this would be the formula. This is called carbon tetrachloride. By the end of class today, you'll know why I called it carbon tetrachloride. But to draw the Lewis structure, which is this, the first step is to total or add up. I'll say add up the valence electrons for the compound. Valence electrons. So in this situation, I have carbon. Carbon has 4 valence electrons. And then when you see that 4 down there, that means you have 4 chlorines. So the chlorines, I have 4 of them. Kid you not, multiplication. Multiplication tripped out my first period honors class. So I'm going to let you look at me while I show you what I'm multiplying. There are 4 chlorines. Everybody still good? What is the number of valence electrons for chlorine, everybody? 7. So look, to find the number of valence electrons, don't do this. I could just be like 7 plus 7 plus 7 plus 7. My son, when he was in kindergarten, figured out repeated addition was multiplication. I hope you have figured that out at some point in your life. Okay? So instead of doing that, because repeated addition is multiplication, I'm going to, this is crazy now. So I'm going to take 4 times 7. No, y'all don't understand. That sums like 4 people. I'm not kidding. So anyway, 4, that gives me 4, and then 4 times 7 equals 28, and then you got to add them up. So 32, okay? The number of valence electrons for these atoms in this compound is 32. That's the most important step. Because here's the thing. When we talked about yesterday, what are the most important electrons in bonding? And you said valence electrons. They're the only electrons involved in bonding. So this is a visual representation of how things bond. So you ought to have the right number of electrons in your picture. So when you get done drawing this, your picture should have 32 in it. And this is the final answer. So 2, 4, 6, 8. Y'all know that line's 2, right? 2, 4, 6, 8, 2, 4, 6, 8. Turns out that 8 times 4 is 32. I did that multiplying thing again. You okay? All right, just checking. So that's the first step. Now, the second step does not apply to this, but I want you to have a beautiful list of steps that you can follow. So if it's an ion, which this is not, if it is an ion, then adjust the electrons as needed. So if it were from the do now, okay, that I would need to add 2 electrons. Okay, so basically I would go, how many does sulfur have? 6. And then how many does oxygen have? 6, and there's 4 of them. So that would be 6 times 4. And that would give me 30. And then it had to have 32 though. See? Did I say that too fast? 6 plus 6 plus 6 plus 6 plus 6 is 30. And then 2 more is 32. So, if it's an ion, you have to add electrons if it's an anion, or take them away if it's a cation. So that does not apply to this compound, but in the future you will have to do these. So the third step is to draw a single bond to each terminal atom. That's the end ones, right? Usually they just need one bond. So in this case, the chlorine just needs one bond because it has 7 valence electrons, and one more bond will give it 8. Processing. Okay. To each terminal atom from the central atom. So in this situation, it was CCl4, and so I'm just going to go like this. You can see how this is a very difficult step. How do you know which one's the central atom of this ring? That's such a good question. It's the first one. It's always going to be the first one. And the reason it's always going to be the first one, the way you name things, right, compounds, is the least electron, like, hang with me, y'all are smart. I can't walk over there because it'll cut out the talking. But the least this is only going to be nonmetals, right? Covalent, yeah? So look at the periodic table. Look at your nonmetals. Look at boron all over. So the least electronegative element goes first when you name. That's the convention. That's the way to do it. So the least electronegative one, like if you look carbon, nitrogen, those will be the one that goes first. And if you think about it, the ones farther to the left need more bonds to have a full octet. So they'll be in the middle because they'll need, like carbon needs 4 more electrons. So if you look at the name CCl4, the compound, how it's written, it will always be the first one, but I didn't want to just tell you it's the first one. It is the first one, but the reason it's the first one is because when you name, the least electronegative comes first, basically the thing on the left. And those are the ones that need the most valence electrons. Hopefully you got that. If you don't, that's okay. You'll understand later. It's the first one. Goes in the middle. I can just tell you that, but I don't like to just tell you like easy ways and cheats. I like you to actually understand what you're doing. Because some of y'all are be taking AP chemistry. Anybody gonna be taking it next semester? No. Some couple people in first period were. So anyway, step 4 is to fill the octet for the terminal atoms. Please recall that hydrogen only needs 2 electrons for a full octet. I know octet means 8, like I know that, but I should have put the quote marks around octet. That's really what I meant to do. Oh, that was so fancy. And the reason for that is it's your sodium gas is helium, right? And that first energy level, if I draw the Bohr model like I did before, has 2 electrons. So what's going to happen is you're going to be like, I'm going to draw little dots, dot, 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 dot. This is what people do. Do, 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 do. And then they feel real good about it because most of them have dots like this, but that ain't right. So just heads up, pro tip from somebody that's graded way too many of these papers. So in this situation, I am going to do that. So I have CCl4. So same stuff. I'm just adding to it. Boop, 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 boop. See how I'm filling the octet? That each chlorine now has 8 valence electrons. Because 2, 4, 6, 8, 2, 4, 6, 8. Okay. So no problem there. And then this one is actually done, but there are more steps in case it's not. You got that down? I hear dots. I hear like click, 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 click. So the next thing to do, there's 3 more steps that you should write down for the more difficult ones. The 5th step is add additional, or add extra, I'll say extra, or leftover would be a good way leftover electrons to the central atom. And we'll do one like this in a second. So you don't have to write this down, but in this situation, let's see, that would be 21. Don't let my math magic trip you out. So 21, that one's actually not going to work. 21 plus 4 is 25. Never mind, this isn't a real compound, but I was going to try to show you something. If I did all the little dots, you know, not a real compound, doesn't exist. But if it did, and let's say, you know, this is, what, 8 times 3 is 24. If it was supposed to have 26, it doesn't. But if it was supposed to have 26, I would put the 2 extra right here. And I'll do one like that. But that's what I mean. Like if you have extra, if your picture's supposed to have, you know, 2 more than you actually have on your paper, you're going to put the extra. So the next example I'll do will have extra. So that's what I mean. Put 2 little dots. Okay, and so step number 6 is to create double or triple, sometimes there's triple, but not normally, triple bonds as needed to complete the central atom's octet. Okay, one more step after this. On the example that I did, carbon was looking like this, and so it needs to have 4 bonds, and its octet was full. So I don't need to make any double bonds, but sometimes you will. And then the very last step, and it's short, thank you for being patient, is to, if it's an ion, which that one was not, you would put brackets in the charge around it. And the charge will be a superscript. So if it's an ion, you're going to put brackets in the charge around it. Most commonly missed points on this quiz and subsequent test is that people will put a bunch of dots on hydrogen and people will forget to do this part. Okay. So, you ready to do another example? Yay! Okay, yeah. If you're not, we're still doing it. So, you got it? Great. So let's do pH3. So pH3, again, P is going to be the central atom. Listen, don't start drawing stuff until you do all the steps. So we're going to do all the steps, and you're going to have to help me. I don't know all the steps. Do y'all see any paper in front of me as I wrote that down? So, help me out. Max, what was the first step?
Add up all the electrons.
So I have 1 phosphorus, that's 5, and then as far as the hydrogens, I have 3 of them. So that's 3. No magic, just multiplication. I'm still laughing about that. So it turns out that 5 plus 3 gives me 8. So my picture, my Lewis structure, should have 8 electrons. If it doesn't, then it's wrong. Because that's the point, right? So step 2, it's not an ion, so that is not applicable. Okay. And then step 3, yeah, I have 3, that's okay. What is step 3? Could you tell me, Robin?
To draw a single line to each terminal atom from the central atom.
Okay. And so, what's step 4, Erica?
To fill the octet for the terminal atom.
Okay. So I'm filling the octet. Whee! Are you drawing dots? Are you? Don't. I did that on purpose. Like, I even made a funny face. Don't do it. Don't do it. So the octet for each terminal atom is full. Hydrogen doesn't get anything but a line. Because that means 2, right? Okay. So, Cassidy. We miss you, Cassidy. Nelson, what's the next step? So step 4 is NA. What's step? So what's step 5? What's step 5? Yeah. Okay, look. This is what people do wrong. So in a minute we're gonna make double bonds and you'll forget this stuff. And then I'll be like, remember? And you'll say yes. So you have 8, but this diagram only has 6. You see how I did it? So are there extra? Yes, indeed. And so they go on the central atom. Then step 6 and 7. 6 is for if the octet is not full for the central atom. It's full, isn't it? 2, 4, 6, 8. And then it's not an ion, so that don't matter. Yeah, it's good. Let's do a harder one. Whee! Next we'll do nitrate. Now, listen to your brain as you think. Can you immediately pull out the formula for nitrate out of your brain? Because if you can't, you got a quiz next Wednesday, so you need to study that. Nitrate's Nick, and Nick's a baby camel. Nick has 3 consonants and 1 vowel. So look, you see how I'm just putting a minus sign? That means -1, but you don't put the 1 because you're better than that, okay? You can if you want. I don't care. All right, so let's do the steps. Step number 1, count the valence electrons. Whee! This is, I almost put a 6 in. That's all right. This is 5, and this is 6 times 3. And so that's 18 plus 5 is 23. And then step number 2, what do I need to do? Kyra?
For step number 2, you adjust electrons if it's an ion.
And it's an ion. So what do I need to do to 23?
Take 3 away. Or add 3.
Wait. How many do I add? What's the charge right here?
1.
So how many gotta add?
1.
Okay. So the 3 down here on the oxygen is meaning that I have 3 oxygen atoms. A subscript is how many atoms, and then the charge is up there. So there we go. So I'll have 24. So my final Lewis structure should have 24 electrons. If you know these steps and you practice, like, you can't mess up your quiz. Because if everybody has a full octet and then you have the right number on your picture, then you're right. Okay? So anyway, number 3 is to draw, and I'm going to scoot down a little bit, is to draw the central atom with the terminal atoms around it. So N and then O, O, O. Okay? And now step 4 is to fill the octet for the terminal atoms. So what I was saying about hydrogen is you'll get used to making little freckles, and then you'll forget that hydrogen doesn't get any. So they don't have any, these are called lone pairs. That's the word for those, is lone pairs. Don't worry about that too much. We'll get into that next week when we make marshmallow models. It'll be a lot of fun. Anyway, no lone pairs on hydrogen. So, do I have any extra electrons? To make your life easier, this is 3 sets of 8, which is 24. So no, I don't. So I can't do this. Don't do that. Nope. Whee. And then the next step is to add or create, is the right word, any double or triple bonds if needed on the central atom if it doesn't have a full octet. Does it have a full octet? Does it? 2, 4, 6. It doesn't. So this is what I'm going to do. Pick an oxygen. At this point in your life, it doesn't matter which one. I'm going to tell you what to do in a minute. But just pick an oxygen. Doesn't matter. And then, do you see how I erased 2 electrons? Did you see? Now I took those 2 electrons, and then I'm going to put them right here. And so those 2 electrons will be shared between oxygen and nitrogen. And notice I still have a full octet on the oxygen, 2, 4, 6, 8. And then the nitrogen is 2, 4, 6, 8. And then after doing all those steps, you'll feel real good about yourself, like, yeah, I got it. And you'll forget to do this part. Because it's an ion. Okay? That's what to do. You want to try one on your own? Somebody said no. That was funny. I'm going to make you do one on your own. So, yeah, you don't really get a choice. Let's go ahead and on your own, do for me, please. SiO3 minus 2. Follow the steps. Oh, listen, you know why I told you to get a whiteboard, right? You see how I'm on the erase stuff and move things around? Do the work on the whiteboard, okay, and then you can write your final answer in your notes. So, healthy friends, work together, talk amongst yourselves, and then I'll work it out for you. Don't just start drawing stuff. Look at your notes and follow the steps. I made you write that down for a reason, and it's not because I'm a jerk. I'll give you another minute, and then I will work it out, and then I'll tell you another fancy word. I see several people still working, so that's okay. Yes. Two on the top. So you can't add the 2 on the top unless you have extra. And so the total was the total 28 or 24. So you added up your electrons. Yeah. Mm-hmm. So silicon is 4, and then oxygen times 3 is. You should never have an odd number of electrons because they're gonna, So anyway, when you get 24, 8 times 3 is 24, 50. So when you put on that's on oxygen, you don't have an extra. So if you have extra, that's how that step comes first. Okay. So I'm gonna give you another minute or so, and then I'm gonna work it out, and then I'll tell you more things. still drawing. That's great. The brackets go around the whole thing. If you don't have a double bond, then you did it wrong. Look, okay, stop what you're doing. Look at your silicon. How many electrons does it have? Yeah. Don't erase the whole thing. Why do things bond? What are they trying to do? Trying to share electrons to get how many? So if you have something drawn and it only has 6 electrons, that ain't right. Because that's what went into the bond. Okay, so I'm ready to talk now. So silicon has 4, and then oxygen has 6 times 3. So that's 4 plus 18 is 22 plus 2 is 24. So anyway, actually I need to start it. I have to show you something, okay? So I'm gonna draw this a little bit smaller so I can torture you a little bit in a minute. And then I'm gonna fill the octet. Remember my magic number was 24 that I need to have on my diagram, my Lewis structure. That's 24 electrons right now. I don't have any extra. I can't do this. You can't just pull 2 electrons out of the universe. No. So that's 24. So what I have to do at this point, you should never miss any points on this. All you have to do is make sure everybody has 8. And silicon does not have 8. It has 6. So it's not done. So what is needed is for one of the lone pairs on any of the oxygens that you like to create a double bond over here. And then most commonly missed after that is this guy. People don't do this, but you have to. Let's see. Did anybody pick a different oxygen than the one I picked? People pick a different one? Yeah. Some people pick this one, or some people pick this one. And if you did that, guess what? You're not wrong. So, welcome to honors chemistry. If you were on level, that's where we would have stopped. But there's 3 different pictures for this, right? There's 3 different solutions. Do you understand what I'm saying? Because the double bond could be here, or the double bond could be here or here. I don't know what it is, but so you could have a double bond in these. You got 3 different ways of drawing this, right? None of them are incorrect, but they're not the complete answer. So what you have to do is you have what's called a resonance structure. I'll just start a new page, and then I'll draw it again. That'll make you feel better about having to draw it again. Resonance structure. That is where you have multiple correct Lewis structures. And in this case, you draw all of them. So let me show you what that's going to look like, okay? If I go back to the one that we just did, I have silicon. I did not even make that the right size at all. Just kidding. Let me back up and fun. Alright, so I have silicon, and then I have O, O, O. Don't forget your brackets. And then what you're going to have to do is draw a little arrow, and then draw the next right answer. Look, did you see how I did it, and now I'm doing it again? Is my hand falling off? Am I done?
Yes.
Like I said, welcome to honors chemistry. I shouldn't have put that up there. I don't know why I did that. And then one more. I had the Which one have I not done? This one? I'm singing a song. That's good, bro. Whee! Oh, -1 for me.
I thought you were talking about the little dots. I was like, she didn't mess those up.
So that's really the answer.
What's different about
Everything.
you have to do more work. Oh, just
That would be what's different about them. Yeah. So anybody can take AP later in their lives. Okay, listen. If you're not just blah 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 blah. Really, the thing is, like, there's a single bond and a double bond here, and the real answer is an average of all three. So the real bond on all these is 1.33. The bond order is what it's called. It's an average. So the real answer is 1.33 for the bond length on all three, and this shows that. But this is called the resonance structure. Now, if you have out the practice sheets that I told you to get out, remember that? If you'll take that and you'll just flip to the second page. We're skipping the back of this one for right now. We're going to get there in just a second. But flip to the second page and it says bonding, nomenclature, and molecular practice. And it has a chart. You see that? Are you looking at it? You sure? Get it out. I'll tell you what to do. If you want to learn something for bonus on your quiz, then don't put your notes up. But if your brain's full and you're like, I'm done, then you can put your notes. Well, you'll need them, but you don't have to write anything else down. So you're looking at this chart. We got to make some corrections. So here's your corrections. For number 3, it says SF6. I would like you to mark that out. And I would like you to do SO3 minus 2. Now that's sulfite, because sulfate is SO4. So I'd like you to do that instead. And then on number 6, I would like you to, I was just kidding, number 6 is fine. On number, which one was it? Oh, on number 4. If you want to do that one, you can. Like if you want to challenge yourself. But I'd like you to do NO2, 1 minus. Notice there's a minus sign right there. There's a minus sign. There's a minus sign right there. There's a minus sign. All day long, people haven't written it out on the line. So if you're ready to just practice and not learn anything else, then you do you. If you would like a little extra credit on your quiz, I'm going to show you something really easy, okay? It's really actually simple. Let me go back to a drawing. This is great. So there's something called, this is optional, so you can stop listening now. And if you're an on level, definitely stop listening. Also, if you're not on level, don't worry about resonance structures. So, oh yeah, formal charge. So formal charge is where it's basically you figure out the charge on each atom. So in this case, I would find the formal charge on oxygen, silicon, this oxygen, and that oxygen, all the oxygens. And the formula for it is very complicated. This is a Freeman original right here, but it works and it's easy. It's valence electrons minus 6 plus berries. Inference. Let me tell you what I mean by that. Hush your face, I got you. So this is a stick. That counts as one thing. That's a berry. That counts as one thing. So the formal charge on this oxygen atom right here is the valence electrons for oxygen are 6. And it has 1, 2, 3, 4, 5, 6, 7. So the formal charge on that oxygen, -1. This is very hard, very complicated. If you read it in the textbook, you'd be tripping. But it's just I like to take really difficult things and make them very easy. So the formal charge on this one, again, the valence electrons are 6. 1, 2, 3, 4, 5, 6. 0. And the formal charge on silicon is 1, 2, 3, 4. So 4 minus 4 is 0. And then the formal charge on this one, oxygen, is 6 minus 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7. Just kidding. And guess what? The formal charge on all the atoms should be the same thing as the charge for the molecule. And is it? Minus 1, minus 1 is minus 2. Minus 1, and minus 1, minus 2. It's very easy. I'm not going to do it again, and you don't have to learn it. And I'm not going to make you practice it. But on your quiz, know that will be like a +1, and it'll be like, what's the formal charge on all the atoms in the one you just drew? Okay? Extra credit. So if you want to practice that as you draw these, find the formal charge and then make sure it adds up to the charge of the molecule. All right? And go. You're doing it in practice. Do it on the whiteboard and then move it over. And then know that if you have resonance structures, you're going to have to draw all of them. I have one more thing that will be helpful to you. Listen, you know how you got a little tiny box right there? And you don't have a lot of room for the resonance structures. If you do have let's just pretend I have a big old molecule in here, and then like a bunch of stuff, okay, blah, blah. And then I have another one, blah, blah, blah. Okay, you know what I'm trying to draw there, like a whole thing. You can actually do this, and then you can put one like in a little triangle. Put your little structure in a little triangle. Like, draw it in, you don't have to draw it in a straight line. That'll save you room on your paper, okay? Just make a little triangle. Do I need to draw one in the box? You okay? Just make a triangle. Okay. All right, good luck. Wish you well.